everyone. Welcome to this new episode of the Swift Academy podcast. Today we are in the second episode of the series about Swift performance. In the first episode with Artem and Bogdan, we spoke about performance related to Swift UI. And first of all, to explain what is performance, because we have different definition from the product team to the developers, different approach to define what is performance. And today we'll try to continue with other topics related to performance with Bogdan and Artem. And first of all, welcome Bogdan and Artem. I am very happy that you are with me to the second episode of the Swift Academy podcast.
Yes, hi. We're back with more stuff.
Yes, in the first episode, we finished speaking about the difference between parallelism and concurrency. For me, it's basic and very important topics before we can go further with Swift concurrency and the impact on performance. My first question is for Artem. Do you think that adopting Swift concurrency can have, if you can say, negative impact on some application, become maybe much slower when adopting Swift concurrency and async await? Sorry, Art.
Honestly, I don't think async await made those apps slower by itself. In most cases, migration exposes a wrong mental model. For instance, teams replaced callbacks with await, but they didn't not always revisit where the work actually runs. The problem is that async is about suspension. It's not the same thing as is background execution. An async function can pause at an await, but the synchronous code before and after this point still runs in the current isolation context. So there are several problems I noticed. For instance, before the migration, the old code might have used dispatch queue global. After the migration, the code looks cleaner with await, but it's not the same thing under the hood. You fetch the fit with await, transform the response into rows, map it, update the state, the UI state, and everything looks fine. But if this method lives inside an actor view model, and for example, mapping step may perform also in this view model, the mapping step not always cheap. So you perform it on the main thread, on the main actor. Another thing is when we talk about accidental serialization. For instance, callback code often not always elegant. Hello, Swift UI. But sometimes it started independent work in parallel. During the migration, people replace it with a clean sequence of awaits. And if those operations are independent, the app now waits for the combined duration of every request, instead the only slowest one. So after every await, I suggest to ask two questions. What runs next? And on which actor? If the next step is something CPU heavy, we should move it out deliberately, do the transformation away from the main actor definitely, and bring back only the final state update, because this is the only part the UI actually needs.
Great. But I understand that migration from, for example, adopting Combine or Eric Swift or any code based on delegate, for example, to using async await, it will be, I think, hard working if we didn't go step by step, little step of migration. Adopting should be very intelligent. And what I understand from what you said, Artem, that it's need a lot of experience to do this, especially when we have legacy code based on this kind of dependency. Moving to async await, yes, it should be very elegant. Adopting the new API proposed by Apple, it's a good choice in terms of adopting new technology, but should also think about the impact of performance. There is a lot of confusion about using main actor. It should be the main thread. Difference between actor, thread, all this all these things is not very clear to the community. Okay, with some what we said, the reproachable paradigm that Apple in I think Swift 6.2 insists integrate to facilitate this kind of migration. But what I find from my little experience and also from some discussions that I made with some expert about Swift concurrency, that there is a lot of confusion about adopting async await. That's come to my question to Bogdan. This kind of moving to async await, for me, it's kind of architecture choice, and it can be impact and create a lot of issues when try to migrate to async await. What do you think about this and the impact on the performance?
Yeah, right. Well, I think first of all, in any migration, you need to first understand the code that you're migrating and then understand very well the new technology that you're adopting. So those two are kind of must-haves, in my opinion. And because people that are migrating to Swift concurrency are not familiar with it, they end up making mistakes. So it's trading a framework that you know and understand, even though it's not as pretty, to something that has intricacies that you don't know yet. So the biggest problems I observed in my experience weren't like low-level runtime issues. There were these migration architectural issues coming from the fact that people don't understand the intention of the framework and its APIs. And this is because Swift concurrency optimizes for clarity, safety, cancellation, structured lifetimes, but not for performance. So it wasn't built with performance as its main goal or driver. And what basically happens in many cases is that migrations, technical migrations like this, preserve old habits. So teams try to express the old way of thinking into the new framework, which is not always a good idea, because usually what happens, and you've seen this with SwiftUI, with concurrency, with all these things, is that you have to learn to think in the new way, not try to force your old habits into the new thing. Right? So if you just replace like things like callbacks and reactive chains and completion handlers with nested tasks and async await wrappers, then you're basically missing the point and probably end up with new problems. Basically the old problems, but in a new syntax, if you want to put it like that. So one symptom that I saw a lot in these migrations is that @main actor becomes spread throughout the code base, because people don't understand where they need to cross actor boundaries, so they fix it very easily. Let's make the entire thing main actor. And then everything is main actor: repositories, services, view models, this, that, like everything is main actor. And like Artem mentioned before, this may lead and will lead to performance issues, because you'll be running heavy CPU operations on the main thread just because you fixed the compiler warning and said, yeah, this is now main thread. And the same thing, the same pattern with async, with the async keyword, where you start to make an API async, and then you turn every caller of that to async and so on, and suddenly a lot of entities in your code base become async where they shouldn't, like things like protocols and abstractions. Now every test is async, and call chains and everything. So again, it's basically the same thing. You don't understand exactly how the new concept should be applied and when the boundaries should be expressed, and then you end up marking everything as such. So these are the ones which I just wanted to highlight. And what I basically say here is that the Swift concurrency just exposed some existing architectural weaknesses and basically gave us new ways to misuse concurrency. The problems lie in the way we adopted it, not in the framework itself. So that's my opinion.
Yes, it's great. Generally, when we adopting a new technology, especially for Swift concurrency that come from Swift, I think 5.5, this evolution of adopting of async await and Swift concurrency, there is a lot of changing, and people try to adopt it sometimes without taking the time to understand everything. I understand also that we should, if we try to be up to date with the new things, we try to move to adopting things. But sometimes this choice should be, we try to prepare before. We should prepare, we should understand. Like adopting, for example, Combine or Eric Swift, moving from Eric Swift to Combine. It should be also, we have why we do this, why we move, what are the gain to for adopting. Maybe we have issues in production. Crash, I don't know, in Crashlytics we have a lot of problems because, okay, we make sendable everywhere, we make main actor, as you said, everywhere. We didn't understand what is main actor, the impact of using a main actor or non-isolated or the A pre-concurrency. There is a lot. There is maybe, I think, 20 keywords or wrappers related to Swift concurrency, but we should understand and go to documentation and also from people that use it and are experienced. What interesting me that the problem that you described Bogdan and Artem, it's not come from the Swift concurrency itself, but also for the how we adopt it. From your experience, and my questions for you two, and first of all for Artem, which Swift concurrency do you think anti-pattern that do you see everywhere today? Because we speak about adopting Swift concurrency, but people said, okay, but what are the most things you speak? I think about things related to dispatch group, etc. But maybe we can move forward to more explanation about this.
Yeah, and the pattern I see most often is that Bogdan already mentioned before, is that people use Swift concurrency as an escape hatch. They have some code on the main actor or compiler warning, and they reach for the nearest tool that makes the immediate pain disappear. And the classic example of it is task detached. It looks very close to dispatch queue global async. So people use it to say, please run this somewhere else. And yes, it gets work away from the current actor, but it also cuts the task away from the surrounding context. It does not inherit the same structure. This task is not part of the same context and task tree, and cancellation becomes much less obvious. For me, detached tasks should feel a little suspicious at first. Sometimes they are exactly the right tool, but if the real goal is just to do CPU-heavy work away from the main actor, I would usually prefer to make that boundary explicit in the API, move work into a separate async function with a clear isolation, use concurrent keyword when that is the right fit. And if we're talking about task, in Swift UI, task often shows up in some place like on appear, inside rows, etc. And the problem here in Swift UI environment is ownership. Who will cancel this task? What happens when view disappears? A lot of subtle UI bugs, they come from tasks that just nobody owns. And the right tool in many cases is modifier, visualized modifier task with ID parameter. It is better fit because Swift UI can cancel the previous task when the identity changes. Talking about dispatch group, I still see people blocking async work with this tool with dispatch group. This is usually a really bad code smell. Swift concurrency wants task to suspend. If you block a thread while waiting for async work, you can hurt throughput, and in bad cases, you can even deadlock. And less dangerous, but with code smell too, is pattern is main actor run, which it's good tool. It's a right tool for some specific job, but sometimes people use it as a tape. It works, yes, but It often means that API is not expressing its isolation clearly. If a method updates UI state, maybe the method should be a main actor. If the whole model owns the UI state, maybe this type should be main actor. And personally, I like to keep this split clear. UI state lives on the object marked with main actor, while business logic and CPU heavy work live somewhere else. So to summarize, ask yourself who owns this work, who can cancel it, and what state it allowed to change, to touch. Is those answers are visible in the code? Swift concurrency tends to work really well because this is a really good architecture and tool. If they're hidden behind random tasks and actor hopes, the code may compile, but it becomes hard to trust, I can say.
Yes, I think it's great because this kind of example that you shared, Artem, about, if you can say, bad using of adopting of Swift concurrency tools like Task Run, it's come from my point of view that we didn't understand how and why and where we can use this kind of tools. And maybe it related that we we are not reading understanding very well the documentation. It is not maybe a good example that are related to our projects. Sometimes because we cannot project our understanding to our real life projects, which is for me the main problem in every topics in our life. We understand things, but when we try to apply, we make errors, but it's normal. The same, I think that Bogdan, we have this kind of example, and it's related also to what you said, thinking, the thinking, anti-pattern thinking that we have. We think in delegate, but we try to code in using async await. That's
Yes. I'll answer that. First, I want to underline what Artem said because I really support this. So I think with Swift concurrency, we are now more like open to thinking about concurrency and the questions that answer how this concurrency work happens. So ownership, cancellation, isolation, things like this. So I think this is really important. I encourage you to think about these things, while maybe with the previous APIs that we had, we didn't always think about this. So now it's more obvious, and I really like the condensed, formula that you gave about thinking these things and just making sure that they are clear from a coding perspective. So not starting work that nobody will cancel and things like that. I think that's really important. My point here would be in the line of your first idea where you mentioned task detached. I would say task in general. So in my experience, just treating task as a direct replacement for a dispatch queue async is the anti-pattern that I see a lot. And it's the same thing I mentioned before, is syntax being changed and the thinking is the same. I just want this code to run on a global queue, if you like, someplace, and I'm not gonna own it, I'm not gonna cancel it, all these things. So it's obvious by Artem's list previously that we don't answer any of these questions. So this is just unstructured concurrency, and we should ask ourselves if that is really what we want to do there. And I think a smell would be that answer will say, well, I had a compiler warning, so I wrapped everything in a task. That should probably be like a yellow to reddish flag, and basically tell you, I think you're not getting the full depth of what Swift concurrency is. You should probably go back to the learning board. That's what I do with myself. So I'm not putting blame or anything, but I think learning should be a structured process, and just by watching a video or reading an article is not enough. You have to try to practice. Like, Walid, you remember the mantras in Essential Developer, where before applying to work, projects, you have to try these things in a smaller demo context, if you like. So that's how you learn. And this is basically saying you need to learn more about it. And I'll share some anecdote if you'd like. So I've been with iOS for so many years, and I've seen many generations of asynchronous APIs. We started with threads and blocks and things like that in Objective-C. Now we are to Swift getting to Swift concurrency and dispatch queues before that. And I think every generation have like if you want to call it an escape hatch. So something that developers would use when they didn't know what else to use. So with Grand Central Dispatch, this was dispatch queue async, and with RX, this was the well-known random subscriptions without disposal. And now with Swift concurrency, I think it's task or task detached, like Artem mentioned. I think there's a bit of overlap between these. So just try to avoid these as much as possible and think of better ways to pass the intention of these concurrent tasks besides the actual definition from the code. So think of semantics as well. So that's about it.
Yes, great. Thank you, Bogdan. I understand from your point of view that all that you shared with Artem, it's not really related to Swift concurrency problems, but sometimes it's related for me like an architecture problems. Honestly, the same thing that we faced when you spoke last episode about Swift UI problems. Maybe the same thing that when we try to speak about dependency injection, adopting dependency injection or using service locator, things related to modularization. The problem is not the tool itself. I think not. This is the main idea that I understand from what you said. But sometimes when we try to use abstraction, because task it's abstract, maybe things related to dispatch group, things related to this. We not like to speak about threads. We use maybe or mutex. We use sendable. We not like to speak about databases. We use sendable. We non-isolated things that can abstract the reality, but we sometimes we try to with using a lot of abstraction. The problem of abstraction can cost much more than the problem itself. This is my point of view. I prefer to use mutex than use sendable. It's my point of view. For me, it's not important to have data races detection and compilation. For my point of view, this is what I think, because we have tools to handle this. Okay, we think that this kind of abstraction for people that developers that maybe didn't have the experience, the seniority, they didn't follow all the evolution of the concept, because the concept from Swift come from Swift 5.5. I think there is a little bit of the community, part of the community that follow this evolution. And we come to Swift 6 and say, okay, now we should adopt Swift concurrency. I think there is a problem of, we have a lot of things that we not follow during the evolution. We didn't understand the why about this evolution. And that came to our understanding, and we are not comfortable without adopting. And we come to, okay, we have this problem of migration. We should make task. We should make sendable. But when you ask the developer why you should do this, there is no response to it. No response. They say, because I read this in this kind of article. But why? And this is the problem. I think that when we come to abstraction, maybe it costs more than the problem it solves. I don't know what do you think? We have the same thing, I think, faced when we speak about any view, any publisher, all these things. And for me, I need to understand from your point of view, if you think that abstraction that we faced in Swift concurrency now costs than the problem itself. Artem, maybe. Can begin with that.
Yes and no at the same time. First of all, talking about abstractions, and not only in terms of Swift concurrency, I want to say that I don't think abstractions are bad by default. Quite the opposite. Good abstractions help us separate concerns, it protect boundaries. We can evolve the code base without touching everything at once. And speaking about abstractions, the problem starts when an abstraction ends up on a hot path. For example, what you mentioned before is juxtaposing mutex and actors. We can use it for in the same situation. However, sometimes we should calculate some things before choosing actor because it can be slower. And if we're talking about abstractions in general, I can say so. If the cost is paid once during feature assembly, for example, totally fine. But if the same cost is paid hundreds of times during, for example, scrolling or some kind of rendering, very frequent state updates, so we have a problem right now. My favorite example is a feed. It can be a chat window or maybe a post feed, doesn't matter. A big feed with different types of content. So, for example, some rows are posts or messages, if we're talking about chat window, if we're talking about AI chat window. Other rows maybe ads, maybe banners, some recommendations, media. It is tempting to model every row as item protocol, and it looks clean and good. One input type. We can handle this whole situation without a big switch. It is easy to extend, really clean code. And we can understand, so if we see such approach in the code, we can understand why teams do this. It feels like a good architecture. But during scrolling, that abstraction may be paid for again and again. So depending on how the values are stored and passed around, Swift may need extra indirection in this case. One note, definitely on new Pro devices, maybe nobody noticed. But we don't have only Pro devices, at least for now. And on older ones, it could become one more reason when the frame budget disappears. Talking about Swift UI, as you mentioned, it is any view used as an escape hatch. And talking about abstractions in general, the question I should ask myself, how often do we pay for this abstraction, and how visible is the cost? For something frequent, for heavy feed, I would prefer concrete row view models or some kind of enum of row types. In SwiftUI, I will not use any view as the first choice. I will reach for view builder, for example, or content builder, the newer API, type ls for view builder in iOS 27. Some kind of generic view parameters, as you mentioned before, combine, and any publisher. I'm fine returning any publisher from a public API, but try not to erase every internal step just to make the type signature look nicer. And in Swift concurrency, yes, it is a very convenient tool. It's a great tool, but it has its own cost, and we should not mark everything with an actor, and we should do it deliberately. The trap is that we sometimes optimize for the architecture diagram instead of the runtime behavior. And a good abstraction should make the code easier to understand, but without hiding too much work. That's my opinion.
Yes, thank you. Thank you, Artem. What do you think, Bogdan?
Yeah, it's a great formula, if you want. So thinking about this balance of code clarity, abstractions, and making the code clean versus performance in terms of how many times is that cost being paid. I like this. I'm going to write it down. What I would add here is that, yeah, we talked about abstractions, system abstractions, right? We talked about any publisher, any view, any keyword, if you like, things like that. And I fully agree with Artem's point. What I would probably jump from a bit of a different perspective is that I don't belong here in a performance discussion with this, but I optimize for clarity first, if you like. That's my mantra. Of course, performance is important, so I will defer to what Artem said. But I just try to build code that is easy to understand and easy to change without surprised side effects, if you want like a short version. And that is because, in my opinion, one of the biggest costs in code bases is not CPU cycles and things like that, is humans and later AI that is trying to change the system, the code of the system. So that's why abstractions are very important to expressing your intent and separating between components, things like that, drawing boundaries. So I would start with the clearest design that you can for the obvious reasons. And the goal isn't to have as few abstractions as possible, but more to have the right abstractions in place. So again, there's a trade-off between code clarity and the right abstraction to enable, like Artem said, for instance, in a feed to add new sections and items with compared to the cost of the performance. So that's something that an architect needs to actually think about. But I would start, first principle is make it as clean as possible. Don't be afraid of, abstractions and the performance degradation they might bring, but measure, of course. So always measure, always try to see if there are bottlenecks. It's like Artem said, how many times am I paying the cost of that abstraction? If it's not too many times, then good. If not, then I might change my solution and I might come up with a different abstraction that is more performant. That doesn't mean jumping from all abstractions to all concrete types and direct links between all the components. And I also believe pragmatism is something to be aimed for here. So I don't believe in architecture purity. I don't believe in Swift UI purity. I also don't believe in performance purity. So I think good engineering lives somewhere in the middle, drawing your own, conclusion based on the data and the problem you're trying to fix. And that's why I try to design the best abstractions I can. And I mean custom abstractions like protocols and other abstractions that we put in place as developers until we have an evidence that abstraction is problematic. So yeah, of course, abstractions come with a cost, but they also bring value, and we have to choose based upon these which one fits the solution better. But it's most of the time is nuanced, right?
Yes, great. What I understand for your point of view, Bogdan, that okay, abstraction is very important, but we cannot say that for the first time we can have what we call the pure architecture based on abstraction. It's working of improvement, continuous improvement of our code, and I think that people should understand this. That sometimes the term about performance, we have code performance, code clarity performance, because when we have code clarity, we take less time to maintain the code, which is very a huge important thing for first of all for the team of developers. They are very happy with the quality of the code that exists. New things that come, new feature that we try to integrate, much easy to integrate it because everything is clear. And with this kind of abstraction using protocol or clean architecture or everything that's good as a manner of coding should help developers, products team to have the time of doing the feature will be much less, and the quality of code which should be respected, which for me it's the good balance. Good
right.
time.
And I would add here that a good architecture and a good design evolves over time. So it's rarely the case that you find that from the first iteration. So as you use performance as a measurement over time, and you look at your app's performance, you also look at the performance of these things that you mentioned, adding new features, maintainability, regression numbers in the specific area of the code, and your design will evolve with it. Abstractions will evolve with it. So usually at the beginning, in my experience, you don't put in the right abstractions just because you don't understand that well. And over time, as you add more code, more features, you understand the system better, then you gain new insights, and you say, oh, actually, I can structure this in a different way. That's why it's important to keep your code base evolving. And like I said, one dimension is performance, and there are many dimensions that we look at when we I don't know, identify areas that need to be improved. So that's why you have to keep an eye on all of these and think about what you're spending time on. If you spend a lot of time on fixing performance, then yeah, you probably have some root problems in the way you've chosen, I don't know, the frameworks, how you use them, but there are many more things that you need to care about. This is the point I always stress, because people think like, oh no, but I wrote this abstraction now, and now I will do my best to keep it because it's so perfect, and it's rarely the case. So just don't be too attached to whatever solution or algorithm or whatever you have. It has to pass the test of time.
Yes, and sometimes they said they should not change the protocol because they should respect one of the solid principles. And at this time, okay,
right.
Which very, very, very for me, it's not a real thing. I cannot be confident that my protocol, the different methods that exist in my protocol, are so generic, are so really well written from the first time. I need to change. I'm not in this time. I didn't. I respect, for me, one of the good principle of developing that we are in agile environment, and in our understanding of the code, it will be involved by the time. But sometimes some developers that come with idea that solid principles are should like a religion. We should not change the protocol because you didn't respect solid principle. Okay, but this is my level of understanding at time t, and now at time t2 I have better understanding and I should change. Okay, it maybe impact tests, it may impact different thing, but this is a good for me manner of coding, because maybe I'm wrong, but this is my point of view. Okay, it comes to, I think, the subject now related to performance that I know that Bogdan liked very well. It's the launching of the application. Performance when launching the application, what things that run behind the scene. We have a lot of things that happen, and I hope that you try to explain to us, Bogdan,
Yes.
this.
I will try not to mess it up. And first of all, I think this is really important because the app launch is the first interaction you have with the app. So if this goes bad, then you already have some kind of okay, is this app really what I want feeling? So at first, let's clear some theoretical concepts first. There are two types of launches. There's a code launch, which happens the first time your app is ever in memory prepared for execution. So your app is not in memory. Everything, all the processes have to be done from scratch. And usually this is the slowest type of launch that you can have, and the most interesting launchpad if you want. The warm launch happens on a subsequent launch. So let's say you had your app open, you closed it, but the OS keeps some cached values in terms of binary, in terms of other things. And on a subsequent warm launch, you get a much better performance. Apple has invested a lot in this warm launch. But why I mentioned this is because when you optimize and when you measure, you should be consistent. So compare cold launch to cold launch, warm launch to warm launch. If you mix, you get all kinds of results. Then there is what we call a critical path, which is basically the sequence of work that the app needs to do before the user can have what Artem explained last time as a meaningful interaction with the app. So the first meaningful interaction. And the longer this path is, the slower the app feels. Because even if you, let's say, go past the app did finish launching with options, now we're talking in details, and you are past the launch screen, but if the app is still not usable, then the whole launch feels slower. And as a mental model, I think we can think of the app launch as a relay race, right? Where they pass the stick from one runner to the other. And in this example, if you like, the problem is that every team keeps adding one more runner, and eventually the launch becomes very slow without like an obvious slow runner between them. So it's just an accumulation. Okay, now to just go to the steps of what happens when the app launches. And I mean, from the moment the user types on the app icon to the moment that the user can actually interact with the application. So at first, the operating system launches the process, which means it has to locate the executable, create a process, allocate a memory, and set up the initial runtime environment. And at this point, after the process is launched, the app code has not run yet. At this point, the dynamic loader, also called DYLD, takes over, and it needs to locate and load binaries, like frameworks to resolve symbols. There's concepts like rebasing and binding addresses, but we won't go into details here. I encourage whoever is passionate about these things to deep dive. But basically, we prepare everything from these external dynamic modules for execution. Again, this happens before your code runs. So from a performance perspective, launch has already started costing before you even execute a single line of code. And we'll talk about dynamic modules that get picked up by the DI lead later and see what their impact is on the whole app launch. But right now we're going as a high level, step-by-step process. Then there's something that we Objective-C users cared for in the old days, now not so much, only for... We still get Objective-C, right? Apple frameworks still have it. There might be third-party code that your app uses that has it, or you might have Objective-C. So there's a step where Objective-C runtime is initialized, and we run things like class registration, loading of categories. If you remember what these are, they were the extensions in Objective-C, things like locating selectors and things like that. And also the Swift runtime. So preparation of type metadata, protocol conformances, runtime initialization, things like that. And I will repeat it at this time. Again, nothing has been executed from your app's code. Now the UI application starts the app, and the lifecycle of the application begins. Historically, this was UI application main, then it evolved to add main, then we added app delegate, later scene delegate, and the recent addition to this stack is Swift UI at app entry point. So all these are ways to tell the system what is the entry point of the application, what is the primary execution path that needs to run. So now the system basically gives the execution to your process and to that particular part of your binary that is marked with the mentioned keywords. And now our code starts to run. So as you see, a lot of things have already happened. And this is basically where our code starts to run, is where teams focus a lot. And we focus on dependency injection, service setup and startup, analytics, feature flags, like all the things that we usually want for various reasons in our app launch, logging, getting remote configurations and things like that. And this is often where the problem starts because we want to do so much in this critical path. And at the next step, we have gained control, but we still have no UI. So at this point, we have to initialize the main UI. So the app will prepare the root view controller or the Swift UI scene with the initial state, with the navigation or stack or whatever else needs to be there. And then it will lay out and render. And at this point, we get into a state where the first frame, if you like, is ready to be displayed, and it appears on the screen. So this is the milestone, if you like, where users are interested in, and because they actually see the first frame of the application UI, and the application delegate is not finished executing yet. Then there is what we call the first meaningful interaction, and this is often forgotten because the app may be visible, like we said, so the first frame is drawn, but can the user tap, scroll, search, navigate, whatever they want to do? If not, then we technically can't say the launch is finished. And why this matters is because there's this misconception that launch starts when my code starts. And as I explained, that's not the case. There's a whole process combining the operating system with various components like the dynamic loader and others that execute before your app executes. And launch is such a big thing, and every one of these things can go wrong or accumulate various durations that as a whole present the user with a large weight, basically, before they can interact with the app. So during launch, we need to think about some principles, like, do we really need that block to be executed? I mentioned this in the last episode because, product owners and analytics teams and everybody will push us to execute a lot of code, to have our app basically do a lot of setup in this critical path. But we also need to push for what is at least a decent app start. And I think this was, at some point, a cold start was targeting 500 milliseconds. I think now it's even less than that. Used to be a good number. I don't think it is anymore, but maybe it is. It really depends, again, on the things that your app does and how you can, as Artem explained, how you can do various things to give a sense of progress. So for instance, using like a skeleton loading or things like that, that may gain a bit more I don't know, time from the user. But again, we need to think about all these steps, and especially the ones which are in our hands, in our code. We need to think about, okay, are these mandatory to be executed before we finalize the initial app sequence? And usually launch performance, in my experience, is just reducing this critical path, if possible, because at the end of the day, most of the things there we want to have in the app is just a matter of, okay, can I actually move these in a different sequence so that my app start is faster? So I hope I didn't bore you to death with this.
Yes, thank you. It's great just to understand the different life cycle of launching the application, because now when we launch Xcode, we have what we call the dynamic loader that launched with some message that we have in the Xcode build loggers, and people, the majority of developers, maybe sometimes they find this kind of problem, especially when we have this in, maybe when we have exe files, when there are some outlets that not right, we find the DY dynamic loader that, okay, but I didn't find the outlet. And we said, why do you exist? This is the role of dynamic loader sometimes to check this. And really, I think it's very interesting to understand how the application launch, because we are developer. If we don't know how our application, what is the different steps that the application passed, for me it's a problem, because we sometimes we cannot explain this life cycle. We have some knowledge about the different. We think that only the life cycle of the application is related to the different delegate, did finish launching, did open background, or this. But before this, we didn't understand. That came also to a question related to, you said that loading frameworks, but you know that, Bogdan, that we have two, I think, main different type of framework. We have static framework, dynamic framework, and now I think we have the mergeable,
Yes.
the third type, the mergeable framework. People from the community said that we should use static framework from some reason, but sometimes we need to have kind of dynamic framework. First, the difference between dynamic and
Yes.
static frameworks, and what kind of use cases that we adopt to using dynamic framework.
Again, some theory at first, but I think a very important topic to be able to understand, because we use these modules everywhere, and you'd better know, at least from a theoretical point of view, okay, what is this actually? And I think, first of all, there's a lot of confusion between module, library, and framework. And to give a short answer here, they're kind of used interchangeably. We used to have libraries with a different extension, and later Apple came with a wrapper for a library where it's basically like a folder that can contain a library and other things as assets or other things. So they're almost the same thing. The framework is just a wrapper, and the module can be either one. So people will use that interchangeably. That's one thing. Then, like you said, yeah, static and dynamic. This comes from a low-level concept, which is linking. And we have a different component from the compiler, which is the linker, and I will explain how this works. Basically, a static library or static framework is a module that is built that where its resulting binary code will be copied into the final app executable. So there won't be any reference from our app to a library or framework. That code will just be embedded into our app binary code. And from the operating system's perspective, that framework doesn't exist. It's just our app binary. And of course, if there are assets, they will be copied over to inside our app bundle, but that is like a separate step. And dependency managers usually take care of this. Now, a dynamic library or framework is a separate binary that ships alongside our app. And I'll explain a bit how we came to have this, because it's important to understand what they are good at. The main thing here is to understand that when we talk about dynamic libraries or framework, the dynamic loader has to locate, load, and prepare this binary for use before our application can use it. So historically, dynamic libraries were designed primarily for macOS. And they solved a very important problem. Multiple applications could share the same library installed on the system. And this wasn't invented on macOS because Windows had it too in the DLLs. Everybody has seen the DLL crashes at some point from Windows. So it's basically the same concept of a dynamically loaded library, DLL or DYLD in terms of Mac. And the benefits were great. Right? We have smaller applications. You could have independent deploys of these shared libraries without affecting the application code. We reduced application, things like that. Then iOS came. And in iOS, I think Apple built a very important principle, which is the sandbox. And the sandbox basically draws like a sandbox for your application, where the application cannot reach outside of the sandbox. Right? So it can only access system libraries, and that's it. And that brought the limitation with it that we can no longer share frameworks or libraries between apps other than the system ones. Now the concept that we had on Mac is no longer applicable here as it was designed, because you cannot independently update such a framework on the device. So the, let's say, biggest benefit that was initially existing to these dynamic libraries just was basically non-accessible. And the cost remained, because there is a cost, which I explained. And the cost is that the dynamic loader has to do all this work. And as you can imagine, it's risky, because you're relying on an interface, on an implementation of an interface that will exist at a certain location, respecting the contract that you expect it to have, but there's no guarantee. So now the dynamic loader has to say, okay, is the framework there? Can I locate it? Can I load it? Can I verify it that it's not an altered version that has, I know, been maliciously been changed? To resolve the symbols there, like are all the symbols that I think are there included and things like that. So it's a bit more complicated process. That's why it requires more time. And basically, this translates into the fact that the more dynamic frameworks you have, the more work your app needs to do at launch before the first screen is displayed. And this used to be a real big problem when they introduced this in iOS. Then Apple worked a lot on improving the app launches of multiple dynamic frameworks or libraries, but it's still something that can go out of hand if not checked on. So it's very important to understand this thing, to keep an eye on this. And it's important because loading all these libraries is on your launch critical path. You can do some alterations. I've seen teams experiment with DL open, so trying to open them at runtime, but this can get very, very complex. So I think only a handful can actually master these techniques. So for most people, all the dynamic frameworks that you have will be loaded by the dynamic loader at app start, with the cost that I mentioned. So imagine if you have a 50 or this, then you were talking here about seconds stolen from the user at app launch. And I will share a bit of a history with this issue that I had. So I was working in a big team, I think 30 developers. We had a big code base, and at some point we were using CocoaPods, which was the go-to solution back then. I don't think SPM was even invented. And we basically had a lot of third-party modules integrated through CocoaPods. All was nice, no problem. The default was with CocoaPods was static libraries. And at some point, for older folks that were using them, CocoaPods team added this use frameworks instruction in the pod file. And they didn't support static frameworks yet. So what this means was that instead of static libraries, you would get dynamic frameworks. That was the change with one line of code in the pod file. All the dependencies were resolved as dynamic frameworks. So nothing else changed. The same code, the same features, the same app. And what happened for us was we went from around 1 second or less of app launch time to 5+ seconds. Even worse on some devices. There's a watchdog process that checks for the app launch, and it will kill your app if it doesn't launch in a particular established number of seconds. I think it was 10 seconds then, and we even had these kinds of reported issues where the app would not launch in 10 seconds. So you imagine how bad this was. And the only difference was the packaging of the modules that we have, like I explained. So switching over from static libraries to dynamic frameworks brought this huge performance cost on our app launch. And at this point, I realized, okay, like the way we use modules and the way the linker works is really, really something to pay attention to, because it can have these really big runtime consequences. Just for people that are curious. So nowadays, SPM, CocoaPods still deprecated, but There are teams that still use it as a default, have switched to static linking. So they will be using static libraries or frameworks, depending on the actual module that they integrate. But there's still ways to integrate dynamically. Okay, now the question arises, well, if dynamic frameworks are so bad, then why do we still have the option to use them? Well,
Yes.
as with anything, they're not bad. It's just a matter of choosing when to use them. So there are particular scenarios which I will cover where these are, if not useful, in some cases even mandatory. But first, when should you use static linking and static frameworks? Well, for most application modules, I think, in a short term. So that should be like the default way of thinking. So things like feature modules, business logic, networking, utilities, all these things. And the reason for using static linking is that it provides a faster launch because all these symbols are copied into your app binary. So they are launched all at the same time. Actually, I didn't mention this before, but the linker can actually perform some optimization at link time because they can actually see, okay, I have a huge static dependency, let's say 10 megabytes, but out of the 10 megabytes, how many of these symbols are used? And it can strip down symbols that are not used. So this is an optimization that can happen at compile and link time, and it actually can save a lot of your binary size. Right? With dynamic linking, there's no such optimization because you have no idea what is going to be used at runtime. So then you have the full binary. So that's another dimension, if you like. But let's keep the conversation simple. So you use static because it guarantees a faster launch. It's simpler to deploy. No dynamic loader work. Fewer binaries. So when should we use dynamic frameworks? Well, for instance, in plugin architectures, when you want features to be loaded independently and controlled at runtime, when you have transitive dependencies that are shared, because if feature A depends on, let's say, a utility framework, and feature B depends on the same utility, now, if you link everything statically, you'll get duplicated symbols from that utility framework. So you see a warning in Xcode for some of the symbols there that they are duplicated in. At runtime, we don't know exactly which one we want to reach for. Also, there are large organizations where teams own separate deliverables. So in that case, if you want to have like real independence, then you might go for a dynamic framework, which is basically packaging the whole thing up and giving to others to use. Also, it's used for shipping closed source SDKs in some situations. It can be used as a build time optimization because dynamic frameworks can improve incremental build times, but you trade runtime costs for developer productivity. So it's an option, but again, maybe just a handful of people will reach for this optimization. But I think that the biggest one is the shared transitive dependency, probably.
Yes.
Also, tools like Swift Package Manager are quite good today at resolving static transitive dependencies correctly. So you no longer, with SPM, for instance, you no longer see the issues of the duplicated symbols because they can actually detect that, okay, it's the same binary, so I can actually include it only once. But that is like an optimization over optimization. So it's a complex thing that only a large team can actually reach out to. And I think CocoaPods can handle some of these as well. But again, CocoaPods is in a clear deprecated state. So I enjoyed a lot having it around. So that's why I keep mentioning it. So I would say the lesson isn't always use static frameworks, is more keep an eye on this. Start with static in mind, but check for the cases that require dynamic loading, and as Artem mentioned before about the cost, paying the cost. Like, okay, where do I want the cost to be paid? Do I want a faster app launch? Do I want a faster build time? Where do I want to move the cost? Because there's always a cost to any. So I think somebody way smarter than me said that there are no solutions, only compromises. So
Yes,
yeah,
I think it's great. There is no best solution. There is it's a question of compromise. If we try to improve our build time, maybe we prefer using static framework, and also for launching the application. But sometimes of the kind of use cases that you shared, Bogdan, about the kind of utility framework, maybe design system framework that we use it. If we adopt static framework for this kind of library, if you can say it, we duplicate, and the cost of duplication also, it's very important. Maybe we have this kind of duplication in DSIM, symbolication. After this, the size of our DSIM will be increased. Some kind of decisions, if we did, the main thing that if we didn't understand what the adoption of static and framework and dynamic framework, what is the impact of the size of your EPA, the time of loading using the YLD tools, all this question should be asked, but sometimes we need people with experience to understand this. If we didn't have this kind of people that have knowledge about launching the application, the time of launching, adopting static or dynamic framework, we can pass the years without that have a good application launching, and the cost of maybe moving from static to dynamic, it will be very high. We didn't understand this cost. This can to my question about if we had this number of framework, we are teams like you said, 30 persons, and we're adopting modularization. The questions that come to what we call dependency graph between modules and the impact of the performance. From my later experience, sometimes I find developers or companies said with modularization, the time of launching of the application will be reduced to the half. Okay, something that very strange to me. But some company, they try to say, okay, but we can improve your dependency graph. And for people that didn't understand what is dependency graph, we have a dependency graph. This is the question:
yeah,
what is the dependency graph? And it can come to understand the impact of dependency graph on the performance of the application, especially when we have non-monolith application. We have, I don't know, 50 modules, 100 modules.
yeah. I think especially nowadays with more people adopting modularization, and I'm afraid some of them are jumping into modularization without fully understanding what it means and what are the costs of modularization, because again, everything comes with a cost. So the maintenance of a very complex dependency graph, which is the, let's say, network or graph of modules and frameworks in your application, increases. So maintenance is much more painful on a large graph than on a small one. But I think it's not just about how many dependencies you have, it's how they're connected. And I think one of the principles that I learned the hard way is to try to keep dependencies independent of each other as much as possible. And it took me a hard road to learn this, because at first I was aiming to, I don't know, reuse everything and basically make a dependency to like shared modules with all kinds of things, like a facade kind of framework. And then later I realized what this does on the cost of both compile time and run time. So I think one of the biggest misconceptions next to the launch of the application subject is that launch performance is determined by what the app delegate does or the scene delegate, and that's not really the case, because like we mentioned, the graph of dependency will determine what gets loaded what gets initialized, what can be deferred, and things like that exist on the critical path. And it's not a numbers game. So a graph with 50 lightweight modules that are independent is probably fine, and you won't see any hiccups on the launch critical path, especially if you are mindful about it. But on the other hand, a graph with 5 modules that eagerly initialize everything may be the worst experience. So measuring is really important, but I think looking at the graph is important both from a performance and from an architecture point of view. So you understand what the dependencies mean, why they are there, and how they actually affect the way we write the code, we read the code, but also the way it operates. So sometimes I think a lot of you have seen this. You're just adding one dependency to your graph. It's like we're adding Firebase. I think a lot of people had this experience where you just added one dependency and suddenly your graph grew exponentially because that dependency brings other dependencies that bring other dependencies, and suddenly you have a lot more modules that depend on each other. So, and especially with these third-party deep frameworks like Firebase, where you have a nice facade way of initializing them, but you don't know what they do behind the scenes. It was the case with Facebook, SDK, and others, where they do a lot of operations, and you actually have no control over it. You just say, okay, SDK start, and that can bring a big cost in terms of, like I said, loading other modules, loading code, executing various things, setting them up. So we might think also, this is from a third party case, but with our own modules, we say, well, initialization only takes 20 milliseconds for, I don't know, feature flags module or whatever. And the graph doesn't care, but eventually, like I said, all these things, they add up and they become this huge launch blocker. And I mentioned all of them, like feature flags and analytics, experiments, A/B tests, networking, remote configuration, like all the usual suspects which we see in an app launch. So there's maybe no single offender, but it's an accumulation of cost for each and every one of these modules, and they have a cost in execution, but they also bring the cost of loading that module. So I think dependency graphs are like a lens to look at the architecture of the application. And that is closer to what I call architecture than, let's say, the UI pattern that we use in the UI part of the code, like having a MVVM or something like that. This is what the architecture is like. How many modules, how they are set up, what are the dependencies between them, how execution flows, if it's in the same direction as the dependency or in the other direction with inverse type dependency. So the launch performance will often expose these architectural issues. Why does this feature depend on that SDK? Do we really need to initialize this thing now at the app launch? Why is a service available globally? Like I said, can I invert a dependency? Can some work become lazy? Things like that. So there's probably, I see a direct connection between improving the launch performance and improving the architecture. There's definitely some correlation there. And again, I will stress is that the goal isn't to have as few dependencies as possible, is having like the right dependencies and with the minimal dependencies between them. So, and of course, on keeping the launch critical path as simple and as fast as possible.
It's great. Let's come to the question of modularization. I think the most difficult thing, imagine that you come to a company that have a code with modularization, and there is a problem. Because when they try to make this kind of modularization, they make a lot of mistakes. And you come to the teams to say, okay, but you have problems. It's not easy to convince people that already have a code with, I don't know, 100 models and said, okay, it's not too good. You make a mistake when you try to make modularization. It's really very, very difficult. And the problem to convince him, because the cost of changing, it's very high. It's very, very high when you have a lot of models. And sometimes it will be not easy to convince him to change. This is the first problem for me. And the second, the tools. Imagine that you have 100 models. How you can detect dependency with the models? It's a huge, huge. Maybe with LLM it will be much easier. No, they can scan all the code, come with the graph of dependency. It's much easier now with using of LLM. But even the LLM can make mistakes. We don't know at this moment. Really, modularization it's come very, very important because, as you said, Bogdan, it's impact the launching, the relation between models, and also the reusability, if we can say, of our models. Because generally, people that make modularization, they are architects, senior developer, technical leader, but the other developers, they use the pattern. They didn't have any decision about the choice. They work on simple Swift UI interface, but they said, okay, but I think it's not a good choice to have this kind of model. I think that but they can convince the senior developer, the technical leader. And for me, it's very, very important question, how we create our models based on what things, okay, you said this is presentation model, data models, etc. Okay, but it's based only for clean architecture, but we are not obliged to use clean architecture. We can use, I don't know, TCA, Viper, or some custom architecture in our choice. This is really very, very hard thing. Architecture, modularization, it will impact performance, teams, understanding. And for me, this is a decision that should be made with a high level, I said, high level determination of the architecture. That's why we have Swift architecture, people that have this knowledge. Really, I'm afraid of this kind of things because years after years, we can sometimes didn't have the control of our code, our launching of application. And that's my question to Artem. From your experience, this kind of up-launch performance problems, it can be sometimes difficult to resolve and to roll back later in the project. What do you think about this? Maybe I'm wrong. From your experience, what do you think that sometimes we have this kind of up-launch performance related to modularization, especially or choosing static or dynamic, it can be not easy to resolve later in the project.
Yeah. Speaking about modularization, I think the primary reason of problems may be that you choose the wrong structure of your dependency graph or of your models graph. For instance, your feature, every feature depend on another feature, and each of them knows about each other. So it will be hard to fix later, and you should begin with a clear graph at the very beginning. Foundation models, service models, and then only feature models, which are not aware about each other. However, there are a lot of different cases which can be not so easy to resolve in the future. And I think launch becomes hard to fix late because it slowly turns from a simple startup path into a place where years of product decisions are stacked on top of each other. Early on, usually, not every time, but usually launch is simple. You create a window, configure a couple of services, and that's it, almost every time. But then one team adds an analytics SDK, another team adds feature flags, someone adds database setup, I don't know. And the interesting part that none of these changes looks dangerous on its own. Nobody creates a ticket in Jira code make up launch slower. It just happens through reasonable local decisions. And I've seen such things. I have seen launch become a shared dumping ground. Everybody owns a small piece of startup, but nobody owns the full path from process start to first interaction. And once that happens, improving launch becomes archaeology problem. You need to understand why each thing is there and what breaks if you move it. The other problem is dependency chain. It was mentioned before. I will repeat it. Config affects feature flags, for example, and feature flags, I don't know, affect routing, etc. So now launch is not only complicated, it's fragile. People are afraid to touch it because one small reorder can become a hidden problem, and some of the cost can happen even before you own the first screen. Code runs, model structure, framework leaking, as what was mentioned before, static initializers, dependency graph. It could affect code launch before the user actually see anything useful. However, I believe the fix starts with ownership. You should choose someone, and this person has to protect launch. You need to know what is really on the critical path, measure it as always, and stop every new SDK or new service from moving into startup work.
Yes, it's great to think that some choice of modularization can not be resolved rollback because we are afraid and we are a human. We understand that this is normal to have this kind of thread of changing because sometimes it's impact all the application and we don't like to be the responsible to be the responsible of a crash or the reduce of the number of customers using the application, especially if the application is used by millions of people. You know that there is this kind of changing can drop it the using of the application because okay it's a lot the application is not good but they make changing and now it's we have a crash. Maybe the intent of the developers of the team it's good to optimize performance to have much less time of reduce the time of launching adopting new technology like Swift Concurrency or Swift UI etc. But we should remember that we are in we have application that is used by people and people they are watching they are using they don't know about how things is working, they just are using the application. And for me this kind of performance related to launching it's much difficult as an issue of performance. Maybe sometimes we have performance related to scrolling. We can fix it. Network request, it's slow. We can investigate the request and we can. But launching performance for me, it's kind of question of architecture. It's almost like of, if you can say the kind of technical depth, very huge technical depth with a lot of dependence, a lot of things that are related to the application, number of modules using, as you said, dynamic static library, relation between framework. This all things for me, it's make that the launching of the application is really it's need talented people, talented developer that understand what is behind the scene. That's why Bogdan, when you speak about what things working behind the scenes, very important. But for me, we should know this. We should know what our application, how it working, and for me, it's very important thing. This is my last question for you, Artem, about maybe best practices. Sorry, what kind of startup work should almost never happen during app launching? Things that you said. You said with Bogdan that sometimes we have analytic people, analytic expert that come. We need to add this. Maybe we are not confident about the choice, but we are obliged to do. But what is the red flags? Things that we don't should have on the startup, on the launching of the application?
I think Bogdan covers this topic pretty well, but I may highlight some interesting cases. But in general, during launch, every task has to prove that it helps the user reach the first useful screen. And yeah, that sounds obvious, but in reality, this line gets blurry very quickly. Everyone has a reasonable sounding argument for doing more work upfront, even when it does not help the user reach the first useful screen. So I would be very suspicious of anything asynchronous and heavy at launch. Network calls, database warm-ups, I don't know, maybe even emoji decoding, prefetching. Some of these things may matter. They just usually do not need to block first value. For instance, if you have a tab-based app, the first screen usually only needs something like auth state or minimal config, crash reporting, but it usually does not need to initialize every feature model behind every tab before rendering anything. You can show one stable screen first and prepare deeper navigation or secondary feature after that. I would be also careful with the naive fix, so let's just run the startup work in parallel. Sometimes that helps, of course, but if the dependencies are implicit, you can trade a slowed launch for a fragile launch. So now the app launch faster on your device, but sometimes breaks because persistence started before the schema was ready or something like that. So launch is the path to first value. If a task does not help a user to see something, understand where they are, or interact sooner, it probably belongs later.
Yes, it's great. What for me, what's fascinating is more that the thing we just mentioned, Artem, are fairly easy to spot, especially in traditional UI kit. When you open the app delegate, when you look at the startup sequence. But what I find now that things changed, especially with Xcode 27, I didn't see anything of the life cycle of the app delegate. Everything gets behind the scene. Okay, we'll check this. And we have now with iOS development, things are different. We adopt, as we said last time, environment injection, server object, dependency container. We have things that launched, tasks appearing throughout the view hierarchy, and the startup work feel much, if you can say it, distributed than it used to. I think now with the new Swift UI architecture and the app launcher behavior is really changing. And it's very difficult now to migrate from a legacy code that used app delegate to the send delegate. And I see, I have one my friend in the WWDC, they shared with us a video about adopting the new send delegate, which are Apple try to, I don't know, oblige. It's not oblige to convince people to not use, to adopt the send launching behavior. I think it's a huge change, and maybe, I don't know, it's a reasonable decision or not, but we'll see this. And for you, this kind of the impact of changing from what we know, the life cycle using app delegate to the modern, what kind of impact we can we have the launch app launch behavior from your experience? I think that you faced this kind to move from app delegate launching to using send delegate launching. Artem, it's a question for Artem. So,
Yes, I would say yes, definitely. And the biggest change that launch, as you said, launch work became easier to hide. In a UI kit app was usually easier to inspect if you experience enough, of course, but usually you opened app delegate, send delegate, maybe, and most suspicious code was somewhere nearby. One note, yes, we can still use UI application delegate adapter in Swift UI, but the number of less conventional, let's say that like that, places where heavy work can be hidden has definitely grown. A bit of it lives in the main app type. Another part appears when the root view is created. More can come from environment injection, as Bogdan mentioned before. Some observable models, task modifier in Swift UI view on appear, and each piece looks declarative and harmless on its own because this is the nature of Swift UI. Because of it, it is very easy to underestimate the total startup cost. Swift UI code can look like UI description, but it's actually building a pretty large object graph. For instance, you create one big app container, inject it into the environment, and suddenly launch is preparing network analytics, database access, I don't know, and dependencies for screens the user has not opened yet. So I think, in my opinion, the healthier model is phased launch. First, do the minimum needed to choose the initial route and render something stable. Then prepare what is needed for the first interaction, and then start non-critical things. The rest should wait, usually, until the user actually enters the feature. I think this is a good way to create a phased launch path for an app.
Thank you. It was really a fantastic episode. We speak about a lot of things related to Swift UI, Swift Concurrency, dependency graph, launch performance. The main idea that there is no best solution. There is usually a cost. That, like Bogdan said, usually a cost. And also we need to understand our tools, what we can do with our tools, Swift UI, Swift Concurrency, how our application work, the launching process. For me, understanding what work is being performed and understanding also that the runtime is actually doing. It's very important. Now we have more abstraction than ever. The impact of using abstraction. Maybe it's good from architecture perspective, but it's not good from performance perspective. It's a question of cost, like you said, Bogdan. We have better tools than before. We have metric kits like we shared with Artem last time, and also an instrument. I think that we need to understand these tools. We'll be much more comfortable with using these tools, and this cannot be realized without experience, without problems, and also reading about these tools to calculate our performance. Now, with the coming of AI, I think we should adopting AI tools to help us to detect app performance. Because sometimes we have log, I don't know, thousands of line of DSIM files or exporting files in bitrise, and we try to detect performance. We cannot read the thousands of lines, but we can, using AI, to understand what is maybe problem related to performance in our logs. It's kind of using to understand, not to adopt without understanding. The problem for me, it's adopting without understanding. This is the main idea, that we do not using result of AI without understanding. We should understand. Because if we don't understand, we are really very complicated problem at this moment. Because for me, it's a really a huge mistake. This comes to my last question to you, Artem and Bogdan. Do you think that modern iOS developers relate too much on abstraction and tooling, and don't enough understand what the machine is actually doing? This is what I think, that we didn't understand very well what things work behind the scene. We have tools. Sometimes we didn't understand the tools, like instruments, like metric kits. But we continue with this kind of problem, and time, years after years, it will not be easy to roll back to detect that we have this kind of less of knowledge of concept. Maybe we can begin with Art about your point of view about this.
I want to look at this question from a bit different angle, and I totally would not frame this as developers are lazy or tools are bad. For me, it is more about incentives. I sometimes remember one story from my university. I studied medicine before software engineering, and our physiology professor asked us once, "So, why do you study to become doctors?" And of course, most answers were like to help people, to treat patients, to save lives. Very noble. And after that, our professor said something like, in reality, many people study medicine because they want a stable profession and a good income. Well, there was some truth in that. And I think software development is similar. Many people came into this profession because it is a good profession, and that is completely normal. But going below the level of abstractions requires extra motivation. You need curiosity, you need some interest in the craft itself. I have worked with developers who clearly had that curiosity. You could see in their code from the very beginning. They use abstractions, of course, but they also understand what happens behind them. They can work with Swift UI, but they still think about invalidation, allocations, different things, main thread work, how runtime behaves. And if needed, they are not afraid to go lower, even to Objective-C. And one thing I noticed now is that many companies are very focused on AI adoption. And I'm not saying this is bad. Of course, AI tools are very useful and I use them a lot too. And your book, Walid, illustrates this point very well. But inside teams, learning programming itself can move to the background. If, for instance, if you plan your performance review, you may be encouraged to focus on AI by management. If you want to give an internal talk, management may be more interested in another talk about AI tools than a talk about the language, the operating system, or the hardware underneath. So modern devices is another point. They also forgive much more than they used to. A lot of inefficient code feels fine on your phone, on a newer phone. So all of this matters, but I do not think this is a disaster. It is just a reality we work in, but if you are building a strong engineering culture, you need to leave space for curiosity because everything changes. Even AI tools change, and they change pretty fast, but the device still has memory, CPU, GPU, thermal limits, and main thread. So we just need to take it into account, I think.
Yes, I think like a manager said to me, Walid, you speak about performance. It's a problem of rich people that have money. They said, well, the application work. We have a crash free, good, very fantastic crash free. You speak about performance. This is a problem of rich and really amazing. What do you think, Bogdan, about this? The problem of team cultures, the curiosity, the passion is about performance, and also about making things good. This is the things that people try to have, or just like Artem said, we work internal. No, yes, with kind of jobs that have good income, not much, very difficult like other jobs. We know this. We are in front of a computer, Mac. We try to. We have a lot of tools, AI tools now that help us, and we are not interesting to this question of performance. Of I'm still curious about it.
Yeah. Yeah. So, Artem, I really like your analogy between medicine and programming. I think it's very accurate because it will be the same. You'll probably get a handful of your colleagues from medicine that are really passionate about the human body, the interactions between systems, why a protein here has a certain effect there, and the same will translate to that same percent of people being really curious about how, I don't know, this, how an operating system works, and what, I don't know, what a compiler does, and all the things that are, let's say, lower level. And I agree with you. It's not a disaster. I do feel a bit disappointed because of the, I think it's a cultural thing where we're looking for the shortest path to results, and this is getting more and more obvious in all areas of life. So I think that's in line with what Apple did in the last years. They made efforts so that more and more people can create apps, great apps, with less knowledge, with less background. I think that's the main goal of Swift UI. That's the main goal of concurrency. That's the goal of SPM, to abstract away all these concepts and technicalities that before were like a showstopper, and to give more folks the ability to write an app, like how easy it is nowadays with Swift UI to just play around and create an app. Not to mention the addition of AI and LLMs that, again, maybe puts another level of abstraction, so you don't even need to understand Swift UI to generate a Swift UI app. So I think the distance has grown between the abstractions or the tools we use and the actual the details of how that works. And I'm not puristic, like I said before. I don't think everybody should know, I don't know, assembly and how the linker works, and I don't know, memory allocations on heap and stack and optimizations there and copy by write and things like that. I think some people need to know that, but not all. We kind of should understand some of the abstractions, some of the tools that we have. So what I have in mind is, for instance, Swift UI, right, hides these details of rendering, invalidation of layout mechanism. Well, we should at least understand what they are to be able to have some kind of an informed decision when we use that tool. Same with async await, same with SPM. Like, yeah, SPM does all the heavy lifting, but at least let's understand why it's linking modules statically. What is the dependency resolving that is being done there, and how these are packaged, how, for instance, how assets are packaged from these dependencies, and how they get resolved into the apps and things like that. And I do agree, nowadays we are more productive than ever. We are faster at producing code, features, apps, but I think we're a bit less curious about these lower level things, the way these abstractions are built. So this is where I'd focus. But again, to me, it's probably, in my experience, I think it's a personality trait, and not necessarily one that you're born with, but one we cultivate in early life. And if you're a curious kind of guy that likes to, I don't know, take things apart and see how they work, and I don't know, spend hours to understand a certain system, then you're probably going to apply that in your day-to-day work. That's my belief. And if you're not, then that's fine. I mean, we do need heavy workers, people that have come to this profession because it's a good profession, like it was mentioned. And I agree with that. It's fine. I just think we all need to maybe accept the limitations. So at least I try to do that. If I know a colleague in my team is better at something, then I say, okay, he probably should weigh in more than I do. I still have an opinion. I still have the things I follow and I care about, but we shouldn't be afraid. And I think, Walid, I also wanted to maybe say something about what you said, where you mentioned the case where one developer cannot convince, I know, his team lead, his more senior coworkers about something. Well, I think we need to listen to feedback. So even if a person does not have, let's say, the technical skills or the technical experience to exactly describe the problem, it's important. So that's why we have concepts like developer experience that in Dora matrix, where we care about, okay, what is the experience of a developer? If a developer, as junior as you want, continuously complains about, hey, adding this feature or change is hard. Whenever I touch this code, I have this problem. Like, we should listen. And we should, like I said, the design and the architecture will evolve. So that would be like a very good indicator to me that something needs to be reevaluated. And you can bring that value without maybe knowing a lot of the let's say under the hood things that I mentioned. Just with the attitude of being proactive and trying to give feedback and to say what you think. So I'm definitely not saying that you should talk directly proportional to their level of experience. It's more of a, okay, how can I contribute to the team I'm in? And yeah, you'll have people that know these things very well. Others will or will not. I mean, it's everybody's decision to invest their time where they want to invest it and how they want to learn things. Everybody's probably passionate about something. So you might not be passionate about compilers, but you're passionate about, I don't know, the recent World Cup matches and who scored the hat trick last night and things like that. So it's all good.
Yes, great. Thank you, Bogdan. Thank you, Artem. It was a great response for the last questions. It's a question of curiosity, passions about things. And I think that we should continue with this kind of checking about iOS or macOS performance application. We have a lot of things that come now with WWDC 26. We should try to improve our knowledge about question related to performance and other things related to Swift UI, Swift Concurrency. I hope that we passed, I think, 2 hours with you for this second episode and 1 hour and a half for the first one. I hope that me, Artem, and Bogdan give you great content to the community about performance, about Artem and Bogdan about their idea about good application performance. It's a podcast. We should read books. We should read article. Join maybe the Essential Developer Program. The program read also great articles from Artem that every 2 days, 3 days, we have a good article about new things about Swift UI with really good content for free. Until now, I don't know, maybe Artem changed it. Just for fun, But we will share with you in the description all the links about and website of Bogdan and Artem. I hope see you guys in another episode about another topics for the community, and try to thank you very much to accept the invitation another time and to be with me for 2 hours and 1 hours and half, and all the working of preparation that we made to this episode, filter of the questions, distributed the response. There is a lot of working behind the scene that people maybe didn't see. I hope that this work will be highly appreciated by the community, and see you maybe in the next episode of the Swift Academy podcast season 3. Thank you. Bye.
Thank you
Thank you.
for having us.
Bye.
Thank you.